Hi everyone, my name is S. Venkatesh and today I'm going to discuss knowledge representation techniques in artificial intelligence. And let's begin the topic. And the techniques of knowledge representation are there are mainly four ways of knowledge representation which are given as follows. First one, logical representations, semantic network representation, frame representation, and production rules. And the next one, the pictorial representation of knowledge representation techniques are see here logical representation, semantic networks, production rules, and frames representation. And by in the next slide, we go first logical representation. And logical representation is a language with some concrete rules which deals with propositions and has no ambiguity in representation. And the logical representation means drawing a conclusion based on various conditions. This representation lays down some important communication rules. It consists of precisely defined syntax and semantics, which supports the sound inference. Each sentence can be translated into logics using syntax and semantics. And the syntax of the logical representation are the means uh, simply the syntax are the rules which decide how we construct legal sentences based on the logic from the given uh, language, and it determines which symbol we can use knowledge in which we can use in knowledge representation and how to write those symbols. And it's all about the understanding the logical and relationship between the sentences of the given language. And and we can also use symbols to represent the relationship between the um, given sentences. And the semantics of the logical representation are the rules by which we can interpret the sentence in the logic. Semantic also involves assigning a meaning to each sentence. And the logical representation can be categorized in mainly two logics, and those are propositional logic and predicate logic. And first, and the advantages of the logical representation. Logical representation enables us to do logical reasoning. And the second one, logical representation is the basis for the programming language. And mainly the logical representation of the can be implemented by using a different types of programming language. Some of are Prolong and some etc. And the logical representation enables us to do logical reasoning, and uh, the reasoning also is a part of the logical representation which we can implement the sentence in sentences. And the disadvantage of the logical representations have some restrictions challenging to work with, and more even it's become a complicated, and the user can also um, it- and the second one is the second disadvantage is logical representation technique may not be very natural, and inference may not be so efficient. So uh, uh, when uh, when comes to a logical representation, it is not that much efficient to represent the language um, more even. And the next representation is semantic network representation. Semantic networks are alternative of predicate logic for knowledge representation. And in semantic networks, we can represent our knowledge in the form of graphical networks. And this network consists of nodes representing objects and arcs which describe the relationship between those objects. And in semantic network, we're gonna use a graphical networks which consists of nodes and arcs. The nodes represents the objects and the arcs represent the relationship between the object to object, and the semantic networks can categorize the object in different forms and can also link those objects. Semantic networks are easy to understand and can be easily extended. This representation consists of mainly two types of relations. One is a relation, that means inheritance, and the second one is kind of relation. For example, following are some statements which we need to represent in the form of nodes and arcs, and the statements are Jerry is a cat, and the second one is Jerry is a mammal, and third one is Jerry is owned by Priya, and fourth one is Jerry is brown colored, and all mammals are adult. And then the first statement is Jerry is a cat. In the statement, see, uh, Jerry is a cat. First, in the first statement, Jerry is an object and cat is also object, but it is a generalized object and Jerry is a specialized object. It means it is an instance of the cat. So, uh, uh, we define a relationship between the Jerry and cat by is a relationship. And the next statement is Jerry is a man, and Jerry is also a mammal. So, um, cat obviously, if Jerry is a cat and cat is a mammal. So, uh, okay. From cat to mammal, we run is a relationship. And the third statement is Jerry is owned by Priya, and the Jerry is a object and Priya also object, but Jerry is owned by objects. So, uh, Jerry is owned by Priya. So, we run a relationship between Jerry and Priya by is bound. And the fourth statement is Jerry is brown color. And it indicates the color of the Jerry, which is a brown. So, drawing the and we run a relationship between the Jerry and wait. So sorry. The color is a brown, and the next one is all mammals are animal, and the mammals are also and mammals. Here the statements indicates that all mammals are animals. So uh, mammals animal. So if this is the semantic representation, and we can see drawbacks in semantic representation. Semantic networks take more constitutional time at random as we need to traverse the complete network tree to answer some questions. So it might be possible in worst case scenario that after traversing the entire tree, we find that the solution does not exist. So one of the major drawback is we need to traverse over and over again through a graph. So to find some relationship between. So if there is no solution that does not exist in the graph, so it makes the time it makes more time. And the second one is semantic networks try to model human-like memory, which has 105 neurons and links to store the information. But in practice, it is not possible to build such a vast semantic network. And uh, suppose Mm, it has to train like a human like memory, and the human like memory which has a 1015 neurons and things, it becomes a very complicated uh, uh, to to bring like a human like memory with the artificial network. So it is not possible to such a vast semantic network, and these types of representations are inadequate as they do not have any equivalent one for example for some none etc. So in semantic network there is a drawback that it cannot uh, suit for the equivalent quantifiers, for example for all for some and none etc. And semantic networks do not have any standard definition for the link names, and these networks are not intelligent and depend on the creator of the system. And advantage of the semantic network. Semantic networks are a natural representation of knowledge, and semantic networks convey meaning in a transparent manner. And these networks are simple and easily understandable. And third representation is frame representation. And a frame is a regardless structure which consists of a collection of attributes and its values to describe an entity in the world. And we all know that, uh, um, for example, frames are the AI data structure which divides knowledge into substructures by representing stereotype situations. It consists of a collection of slots and slot values. The slots may be of any type of font sizes. Slots have names and values with circle faces. And coming to frame representation, we have many frames regarding the corresponding frames which are frame names and frame values, facets, and there is a kind of relationship. Relationship between frame to frame and is a part of. So there may exist different types of values in frame representation and facets. The various aspects of the slot is known as facets. Facets are features of frames which enable us to put constraints on the frames. For example, if needed facets are called when data of any particular slot is needed. A frame may consist of any number of slots, and a slot may include any number of facets, and facets may have any number of values. A frame is also known as a slot filter knowledge representation in artificial intelligence. Let's take an example of a frame for a book, and I know we know that have slots and filters. And slots, I have told before that slots are also known as facets, and slots are known as title of the book is title of the frame is known as artificial intelligence, and genre is computer science. Others Peter Norvig and Norvig, Peter Norvig. In addition, third edition, and year is 1996, and pages are 1152, and this is the one type of frame. Uh, so we're gonna represent the knowledge in this in frames in like frames. And the advantages of a frame representation. The frame knowledge representation makes the programming easier by grouping the related data. When it comes to a programming by knowledge, when it is representation like frames, it becomes very easier to the programmer to know the values of the attributes and minimum. The frame representation is comparably flexible and used by many applications in AI, and it is very easy to add slots for a new attribute and relations, and we're gonna add a number of slots by going to the knowledge representation in addition, and it is easy to include default data and search for missing values, and frame representation is easy to understand and visualize. And the disadvantages of the frame representation are in frame system inference mechanisms is not be easily processed, and inference mechanism cannot be smoothly processed by frame representation, and frame representation has a much generalized approach. And the next one is production rules. Production rules system consists of condition, action, phase, which mean if condition, then condition. It has mainly three parts. The set of production rules, working memory, and they recognize act cycle. In production rules, agent checks for the condition, and if the condition exists, the production rule fails and corresponding action is carried out. The condition part of the rule determines which rule may be supplied to a problem, and then the action part carries out the associated problem solving steps. This complete process is called a recognized act cycle. And for example, if I said the production syntax may be if condition, then condition. So some of the examples are if at bus stop and bus arrives. If bus stop and bus arrives, then action get into the bus. If bus stops, and second one example is If on the bus, unpaid and empty seat, then action sit down. If you get into the bus and buy the ticket and the seat is empty, then you have to sit down. If these are all the conditions is possible, and then you may, if there is empty seat, then you may be sit down. And third example, if on bus and unpaid, then action pay charges. And fourth example is if bus arrives at destination, then action get down from the bus. These are the examples of the production rules and advantages of the production rule. The production rules are expressed in natural language, and the production rules are highly modular, so we can easily remove, add, or modify uh, an individual rule. And the disadvantage of production rules: production rule system does not exhibit any learning capabilities as it does not store the result of the problem for the future use. During the execution of the program, many rules may be active, hence rule-based production systems are inefficient. So, guys, these are the knowledge representation in AI. There are four types mainly. First one is uh, knowledge representation in semantic knowledge representation, production rules, and so these are the four types of knowledge representations. These are logic representations, semantic networks, production rules, and frames representations. Thank you, guys.